In this video, we're going to discuss subnetting IPv6. This is an IPv6 address, written out fully, all 128 bits. This part is the global prefix, composed of 48 bits, represented in hexadecimal. This part would come from an ISP, Internet Service Provider. This is the network prefix. It's composed of 64 bits. This is the interface ID, also composed of 64 bits, mentioned here only to identify it. We'll get back to it later. In this presentation, an example of subnetting an IPv6 address will be covered. As you should already know, the leading zeros in any IPv6 address can be dropped and represented by a double colon only once, and then a 0:0 thereafter. For example, we're given the global prefix of 2001 feed face /48. We have to perform our subnetting in the fourth hextet. Now, Cisco will call this a quartet, meaning that there are 8 quartets. I still call it a hextet because it's represented in hexadecimal. It's written out fully. It's 2001 feed face quad 0 quad 0 quad 0 quad 0 quad 0 /64. We're going to be working in that fourth hextet. 16 bits is one quartet, or as I call it, a hextet. There are 8 quartets in an IPv6 address. We'll be concentrating on the fourth quartet, or hextet as you'll hear me say, which is indicated in red. That breaks down 16 binary digits. We now start the fourth quartet numbering sequence. Remember that each of the 4 hexadecimal digits is 4 binary digits, giving us a total of 16. So 2 to the 16th power equals 65,536 possible subnets just with that one hextet, or as Cisco calls it, quartet. Our binary to hexadecimal conversion chart is on the left. All zeros equals 0, the first one turned on, 1, all the way down through 15. And notice that 10 through 15 are represented by A through F. The network numbering in hex begins. Starting with the 4 digits, the furthest column on the right goes from 0 up through F, and then when it comes there and rolls over there, the first column goes back to 0, the second column starts with 1, just like an odometer of a car. Now we progress on over to the second column being a 2, rolling all the way up, then the 3, rolling all the way up. Each one has to be maxed all the way out until you get up to 4 Fs all the way across. You can continue on until all the addresses are expended. The old adage of where's the beef? Well, there's the beef right there. We've accelerated past here a little bit to get up to where we can go through. So if I were to take time to count out all 65,000 addresses, it would take a long time. So our final address would end up in 4 Fs. This gives us the range of 2001 feed face quad 0 /64 through 2001 feed face FFFF /64. That takes care of our 64 bits for the network portion of the address. But now, how about those 64 interface ID bits, or as I still call them, host bits? If you remember that an IPv4 Class A address has 24 host bits, that gives you 16,777,714 hosts. That's a great start. We simply turn on bit number 25 and voila. That's 1 bit multiplies your host to 33,555,428 hosts. Moving on upward to 30 bits gets you 1 billion and approximately 74 million hosts, give or take a few. By the time you carried out to bit 40, we've just ballparked it to about 1,099,544,000,000 hosts, plus or minus a couple 100,000. So you can continue doubling this value with each bit until you get to 64th bit, because binary, as you move over one place, it doubles in size. My calculator for Windows went as far as 9 quadrillion, 7 trillion before erroring out on the 54th bit. Remember that IPv6 gives us enough addresses for every grain of sand on the planet, or so I'm told, over 340 undecillion. This is our little piece of the internet that we were using just for this demo. From 2001 feed face, quad 0, all the way across, /64 to 2001 feed face, 4Fs and 4Fs and 4Fs and 4Fs and 4Fs /64. Thank you for watching.